today's session on SCR, which is also called as a thyristor. In previous session, we already discussed various power electronic devices such as diode, transistor, IGBT. Now in today's session, we are going to discuss a new power handling device, that is SCR, also known as a thyristor. Thyristor is basically a high power handling capacity device, which is basically consists of combination of two transistors having three terminals as anode, cathode and gate. It is a PN, that is 4-layer device having three junctions, J1, J2 and J3. There are several aspects about SCR, but mostly used in control circuit for handling the higher capacity. Now we are going to discuss about SCR, which stands for Silicon Control Rectifier. As we are going to perform the details about the SCR. I already discussed that it has having high power handling capacity up to 1200 volts and 1500 ampere with switching frequency ranges from 1 kilohertz to 20 kilohertz. When forward voltage is applied to the anode terminal with respect to cathode, keeping gate as a open terminal, then above PN junction is forward bias, whereas lower NP junction is a reverse bias. Junction J1 and J3, J1 is forward bias, whereas junction J3 is a reverse bias. The middle junction J2 is a reverse bias, so that it cannot conduct since J2 is not breakdown. When forward voltage, that is anode to cathode voltage, is large, then junction J1 breaks, forward junction J3 also breaks, and due to the increase of forward voltage, junction J2 is also gets breakdown. So the conduction is always from anode to cathode, like as a diode. Now the question is why we provide the gate signal for SCR. When the application of the forward voltage is anode to cathode, it is very much for SCR due to the higher power handling capacity. But to trigger the SCR by giving the sufficient amount of anode to cathode voltage and apply the gate pulse, that is maybe a DC signal, AC signal or the pulse signal. Mostly in laboratory purpose, we use the pulse triggering for the gate signal. The maximum is the gate current signal, lower is the requirement for the anode to cathode forward voltage. When SCR is a latching device, unlike diode, since it goes from blocking state to the conduction state, that it latches from one state to another state, so it is called as a latching state device. Now in this figure we will discuss about some terminologies regarding the latching current, holding current, forward breakover voltage, reverse breakover voltage. As you seen in the characteristics of the SCR, VBO represents the forward breakover voltage where SCR cannot conduct. But when anode to cathode voltage reaches above the VBO, the conduction is possible when the gate signal is appeared. VBR is specified, that is reverse breakdown voltage, which is specified by the manufacturer. Up to the VBO, SCR is not triggered. When the gate current signal is maximum, it reaches from forward breakout voltage to the conduction state. So the current IL, which represents the latching current, which is related with the turn-on process of the SCR, whereas the IH represents the holding current related with turn-off process of the SCR. As we seen in the VI characteristics, as the gate signal is large, minimum amount of VBO is required for the triggering the SCR. This structure represents the 4-layer SCR and the manufacturing of the SCR, which is represented by PNP and NPN transistor. That is also called as a 2-transistor analogy of the SCR. We can manufacture the SCR by combination of the 2 transistors. One is PNP and another is NPN. There are several applications of the SCR, which is mostly used in trial circuits, diode circuits, control circuits, and high power handling capacity of the SCR is utilized in high power requirement. Thank you.